Hey everyone, so when we talk about digital security, I find it really helps to think of it like building a fortress. I mean, you don't just put up one giant wall and call it a day, right? No way. You build layers of defense, from the deepest foundations all the way up to the highest watchtowers. Today, that's exactly what we're going to do. We're going to build that fortress together, layer by layer, and really get a handle on how modern systems are protected.
All right, so here's the game plan. First, we're going to start at the very foundation, what we call hardening the host. Then we'll expand our territory into the virtual world and the cloud. After that, we've got to secure our troops on the move, our mobile devices. And finally, we'll look at the master blueprint itself, making sure security is built in from the very beginning.
Okay, first things first, hardening the host. This is the absolute bedrock of our security. We're talking about the individual computer or server. Think of it as the keep at the center of our castle. If that falls, honestly, the rest doesn't matter much.
So what do we actually mean by hardening? Well, it's pretty much what it sounds like. It's the process of taking a system with its standard, out-of-the-box settings and systematically locking it down. You're closing all the unnecessary windows, bolting the doors, and sealing up any back entrances an attacker might find. You're turning a generic building into a purpose-built fortress.
So how do we do it? Well, here's a pretty standard checklist. You start with the idea of least functionality. Basically, if you don't need it, turn it off. That alone shrinks your attack surface dramatically. Then you go through and shut down any network ports and services that aren't being used, get rid of those easy-to-guess default accounts, make sure people are changing their passwords regularly, and, this one's huge, automate your security patches so you're always protected against the latest threats.
And you know, security isn't just about software, it's built right into the physical hardware these days. You've got things like the Trusted Platform Module, or TPM, which is basically a tiny, secure vault on your motherboard, just for your encryption keys. Then there's Secure Boot, which acts like a bouncer at startup, making sure only legitimate, signed code gets to run. And with full disk encryption on a self-encrypting drive, your entire storage becomes a locked box that's completely unreadable without the right key.
Okay, so what about controlling the software that can run inside our fortress? You've got two main strategies here. There's blacklisting, where you keep a list of known bad guys and block them at the door. It's quick, but what about a brand new threat you've never seen before? That's where whitelisting comes in. It's the opposite approach. It's like a super exclusive club. If your name's not on the list, you're not getting in. It's way more secure, but as you can imagine, it takes a lot more work to manage that approved list.
So, we've battened down the hatches on our physical machine. But these days, our kingdom extends far beyond that. It's time to push our borders into the virtual world and the cloud. And this is where security gets a little more abstract.
So, let's talk virtualization. This is the magic that lets us run multiple, separate, virtual computers on one single piece of physical hardware. And the magician in charge of all this is called the hypervisor. It's the traffic cop that directs resources and makes sure all these virtual environments stay in their own lanes and don't interfere with each other. It's incredibly efficient, but it also opens up a whole new can of security worms.
And yeah, here's where things can get a little hairy. First, you have VM sprawl. That's when you create so many virtual machines, you literally lose track of them, and forgotten ones are almost always unpatched and vulnerable. Then there's the nightmare scenario, VM escape. This is where an attacker compromises one virtual machine and manages to break out of it to take control of the entire host system. And of course, you still have to worry about patching, but now you have to patch the host and every single virtual machine running on it.
Now, when we move into the cloud, we have some choices to make. You can go with a private cloud, which is like building your own exclusive, high-security fortress. You control everything. Or you can use a public cloud, which is more like setting up shop in a massive shared city. It's super convenient and scales easily, but you're sharing the infrastructure. And then there's the hybrid model, which gives you the best of both worlds. You keep your crown jewels in your private fortress, but connect to the public city for everyday tasks.
And within that cloud, you can choose different levels of service. Infrastructure as a service, or IaaS, is like renting the land and the raw building materials. You build everything yourself. Platform as a service, or PaaS, gives you the foundation and framework to build on. And software as a service, or SaaS, is basically a move-in ready apartment. You just show up and start using it. You can even get security as a service, which is like hiring a dedicated security team to guard your cloud setup.
Okay, our main fortress is looking pretty good. But what about all our scouts and messengers out in the world? Our mobile devices are on the front lines, and they need their own specialized set of armor and rules of engagement.
The answer here is something called Mobile Device Management, or MDM for short. Think of it as a remote command and control center for your entire fleet of phones and tablets. MDM lets you push out security policies, install required apps, and keep an eye on all your devices no matter where they are. And MDM gives you some pretty amazing powers. You can force every device to have full encryption and a strong passcode. If a phone gets lost or stolen, you can hit a button and remotely wipe all the corporate data off it. You can even set up a geofence, a virtual boundary, so that if a device leaves a certain area, like the office, some features might get locked down automatically. Pretty cool, right?
So, who actually owns these phones? Well, in a corporate-owned model, the company buys the device and has total control. Then you have the ever-popular Bring Your Own Device, or BYOD. Employees love it because they can use the phone they already know and love, but it creates a huge headache for security teams. How do you protect company data when it's sitting on someone's personal device? It's a constant balancing act between security and convenience.
All right, for our last section, we're going all the way back to the beginning. We're going to the architect's office, to the original blueprint, because the strongest, most secure fortresses aren't the ones where security was bolted on as an afterthought. They're the ones where security was designed in from day one.
For a long time, software was built using what's called the waterfall model. It's very linear. You do step 1, gather all the requirements. Then you finish that and move to step 2, design. Then implementation, then testing. You can't go to the next phase until the previous one is 100% complete. It's very structured, but it's not very flexible. If you find a design flaw during testing, going back is a massive pain.
And that brings us to the agile model. This is a totally different way of thinking. Instead of one huge, long project, agile works in small, quick cycles called sprints. In each sprint, you go through the whole process: plan, design, build, test, but for just a small piece of the project. Then you review and do it all over again for the next piece. This makes it so much easier to adapt and, crucially, to build security checks into every single cycle.
And that flows right into this idea of DevOps. DevOps isn't really a tool, it's more of a culture. It's all about breaking down the wall that traditionally exists between the people who build the software, the developers, and the people who run and maintain it, the operations team. When they work together from the start, you get better, more secure software, and you get it faster.
And this culture is supported by some really solid practices. Things like input validation, which has a simple mantra: never, ever trust user input. Treat it all as potentially hostile. You've got code signing to digitally stamp your code, proving it's legit and hasn't been messed with. And then you test. You do static analysis, scanning the code before it even runs. And dynamic analysis, also called fuzzing, where you just throw tons of random garbage data at the running program to see if you can break it.
And there we have it. We've gone from the silicon chip on the motherboard, through the operating system, out into the virtual world and the cloud, and all the way down to the individual lines of code. It just goes to show you, real security isn't about finding one magic bullet. It's about building a deep, comprehensive, multi-layered defense.
So I'll leave you with this question to think about. As our world gets more and more connected, with smart devices everywhere and everything in the cloud, if you had to put all your resources into defending just one layer of this fortress we've built, which one would you choose? Where do you think the most important battle is being fought? Is it the hardware, the code, the cloud? Something to think about. Thanks for joining me.